Hi, today we're going to be going over inverse functions. A pretty interesting topic in much of more advanced algebra that can be a little tricky to master. But it's really great to understand because it can really help you out whenever you're dealing with inverse functions. Right, so first, what is an inverse function? Well, put simply, it's kind of when you're swapping the values of a function. When the inputs of a function become the outputs of another function, which then takes in the outputs of your current function as inputs. And if that all sounds like a mess of words, let me try to make it a little more clear with the picture, right? So imagine we have a function that's on an assembly line. And this function performs a certain operation on toys on that assembly line. So it stamps them, or it adds an arm, or it puts on a button on their chest. And every time we have a toy pass through our function, that operation is performed on it. And it'll come out with that operation performed. It'll have that button or that stamp, whatever. Well, inverse functions are sort of like if we had a machine that could undo that process. If we could take in a fully formed, packaged, ready for selling toy, and disassemble it bit by bit, right? If we had a machine that could add a button to it, our inverse function would be a machine that could remove the button from it, and it'd take in a toy with that button, and it would output a toy without that button. So we noticed something interesting. The toy we put in here in our regular function is the same as the toy we output here in our inverse function. And the toy we output here in our regular function is the same thing as the toy we put input here in our inverse function. And this is a very important property of inverse functions. If we have a regular function here with an input and an output, well, that inverse function here, which I read is doing f to the negative 1, or whatever that function name is to the negative 1, takes in this function's outputs as inputs, and outputs this function's inputs, right? So if that all seems still a little confusing, let's try to make it clear with a very, very simple function. All right, so say I have a function, and these are my x's and these are my y's. And so if I put in an x, I'll get a y. Let's say I have 1, 2, and 3. And if I plug in 1, I get 4, and I plug in 2, I get 6, and I plug in 3, I get 8. Well, in an inverse function, these are going to be swapped. My inputs become my outputs become my inputs. So my inputs are 4, 6, and 8. Right? These are now my x's, where before they were just my y's. And if I put them in, I get 1, 2, and 3 as my y. So our x's and our y's, our inputs and our outputs, have been swapped to produce this inverse function. And oftentimes with inverse functions, you'll be asked to, given a function f of x equals 6x minus 1, find f negative 1 of x. And at first, this might seem a little confusing and a little jarring because how are you supposed to find the inverse function if you don't have a nice collection of points that you can go off of? It seems pretty difficult. But we can also rewrite this as y equals 6x minus 1, since this is just another way of representing our output by using f of x or y. And then we can figure out something. In the previous thing we did, we noticed that our inverse function swapped our x's and our y's. Our y's became our x's and our x's became our y's. So if we want to find our inverse function's formula, let's just do that. Let's replace our y's with x's and our x's with y's. And at this point, we've inversed this function. And since y is our output, another way to write this is 6 at the negative 1 of x minus 1. And all we really have to do here is just isolate this variable, get it all by itself. So I can add 1 to both sides. And then divide by 6. And I'll be left with 1/6 x plus 1/6 equals this by inverse. So I have successfully inversed my function. So this is what we're going to do anytime you want to inverse your function algebraically. You're going to place your x's with y's and your y's with x's, and then just solve to isolate your y, just like you would if you were finding a normal function. Now, another interesting thing that happens with inverse functions is when you look at them graphically. And again, we're going to use that same mindset of when I'm looking for an inverse function, I'm going to spot my x's and y's. So say I have a nice cubic function that looks something like this, right? And I'm given, find after the negative 1 of 4. At first, this might seem a little confusing. We might be tempted to look at, okay, where's 4 on the x-axis, and then find the point that goes along with it. But this is an inverse function, right? And since we know our x's and y's are swapped, we can say, well, for a regular function f, right, this is equivalent to our output, right? And this, so for some value x and f of x, it equals 4. So that's the same thing. And this, of course, is equal to that given x value. Because remember, our points are swapped. Here we have x comma 4, and here we have 4 comma x. Our points are swapped, but this is the graph of f of x. And so really what we're looking for is, hey, what point matches this? Where is my y value 4? And then what's the corresponding x coordinate? And that's the answer to the inverse function of f with 4 as an input. That's the answer, because this is the x that goes here, and this is the y that goes here. And if we can find this point, we can find that x value, we can solve this, right? So the easiest way to just say is, okay, I'm going to draw a line, a horizontal line, through the y-axis. And I say, oh, hey, it intersects, it's our y value is 4 right here where it intersects. And let's say that just happens to be where x is 5. So 5, 4 is a point on our line, right? So if I plug in 5 into my function, I will get 4. But in our inverse function, we want to know what if I plug in 4, what will I get? And since we know our values are swapped, we know we will get 5. And that's how we with inverse functions graphically. We do the same process of reversing the x's and our y's, and know that, hey, if we're asked to find the inverse function given an x value, well, that's really our y value. And we're looking for what point on the graph has wherever this value is inside the parentheses of the inverse function as a y value. And that is the interesting relationship between functions that we call inverse functions. I hope you found it helpful, and I hope you have a great day.